Hello and welcome to the Machine Learning at Home. Today I will speak about small function, which however might be very important if you want to understand the importance of characters in multivariate dataset. Actually, this function, so Gini coefficient of inequality, is frequently applied for economical studies, for salaries, for budget stuff, but you can use it also for machine learning. I will show how. First of all, you need to load my own package. So library, Shipunov. And be sure that this is 1.17 or older version, because I introduced Gini function most recently. So recently that function went to my package, but you can find some analogous functions in multiple other packages. Well, but for making life simple, I will use my package anyway. So first of all, you can apply it to any kind of data. Function called Gini with uppercase, and for example we can take the iris data and apply it for all columns except the last one with the function sapply. Sapply iris without column number 5, and this is a name of function Gini. Easy enough. And then you have some numbers. So these numbers represent the inequality of data. So what does it mean? It means, for example, then in sepal width, the inequality of data is less of all. So most numbers are similar to each other, and there are no outstanding numbers which are much smaller or much higher than others. So if you remember how Gini is used in economical studies, countries with low Gini will have almost all people have a similar salaries. So this is exactly what I mean by the sepal.with character is like a less unequal or more equal to each other. All data is similar. And petal.with, this is a kind of column which contains lots of inequality in data, and this is important. This column is probably most informative and can be used for making classification. So the more difference is within column, the more information you can take out of it, and it is probable, well, it not exactly like should be clear from what you see, but probable that you can take your classification out of petal.with alone, or maybe out of petal.length and petal.width alone, because these two columns have maximal inequality. How to check it? Well, we can apply, for example, random forest, which actually uses the same Gini approach for this famous random forest classifications, and also it has function importance, which will show you importance of individual variables. They're actually very similar to what we see, but let us prove it. So first of all, a library, random forest, random lowercase, forest uppercase. Okay, it's here, and then we can make a model. So I will not make any train data. I simply use like fifth column as data which represent the final classification, and we'll use all four first columns for making this classification with random forest. So we'll use whole data as a training in more simple words. Iris RF will be random forest of species, because species is the name of last column, against everything else, against four first columns, and data name equal to iris. Okay, and finally we can run importance of this model, iris.rf. And you can see that importance according to random forest is very similar in appearance to what we obtained from the Gini. As you see, the most important is petal dot width. Slightly less important is petal dot length. And two other characters of sepals, are less important of all, and least important is sepal dot width, exactly character which has smallest Gini in our first approach. So instead of running random forest and similar tool, there are many, you can simply run Gini on your columns and see which of them is most unequal, and that one might be the goal, might be column which might be used for classification of your data. So Gini is quite useful in a kind of introductory analysis of your data. So this is it for today. Thank you very much.